Smile.
Smile. Yay. Now that we are done with the group photo, let's do the serious business. So,
Like, we can run away. Like, we already done. Like, we have proof that we've been here.
okay, so welcome to the session Code Coverage MythBusters. Before we start, let me introduce my colleague, staff software engineer at Sonar, Marharyta. She's also a Kotlin Google developer expert, so please welcome her on stage.
Yeah, and I'm happy to introduce my colleague and my co-speaker, Evgeny, who is principal software engineer at Sonar. And by the way, it's like 3 days since he is a Java champion, so let's congratulate him. And he is a JaCoCo project co-lead, so he'll be responsible for code coverage part of this talk.
And you will be responsible for MythBusters, right?
Probably.
Okay. So before we really start, we were asked to put this huge disclaimer. We work in a great company, Sonar. You might know this company. By the way, let's check. This company creates Sonar Cube, Sonar Lint, Sonar Cloud. Who uses those products? Who knows about them? Don't be shy. Raise your hands. Thank you.
You too.
Really, don't be shy. You might hate those products. Today, we don't care, because whatever we're going to tell you today is not connected with our employer. Whatever we're going to tell you today is our own opinion. And our employer can only dream that he owns this opinion.
And
Did I forget something?
No, I think there is one more important thing that you should know about me. I'm Ukrainian. I was born and raised in Kyiv. And you know, currently, my country has problems with our neighbors. We are at war, and we need all the help that people can give to us. So this is the QR code that you can scan, go, and this is Trusted Charity Fund. Or you can find any other charity fund if you feel like you want to support Ukraine. That will help a lot. And interesting fact, last year I've been here at DevBcn with exactly the same slide, with exactly the same QR code. And here I am this year with exactly the same slide, this QR code. And I really hope that I'll be here next year, but without these slides. Thanks a lot. The most important and serious part of the talk is done. Let's have some fun.
Apparently, I'm also going to be responsible for some fun.
We are doomed then here.
We'll see.
So as a person responsible for MythBusters at this talk, let me check quickly. Have you ever seen MythBusters?
Yay!
Yeah. I remember I seen this TV series a long time ago when I was a kid, and I really enjoyed it. And that's why we tried to use it as a sort of a plot twist in our talk. So in simple words, if you don't know what it is, this is a series where two people collect some common beliefs, common myths, some like facts, and try to reproduce the circumstances and either confirm or dispel this common belief. So we are going to do the same here in this talk with all the myths or some myths about code coverage.
Do you want me to pick some myth?
Yeah, I think that I let you choose some myth because you're code coverage tool maintainer. Probably you know better.
Before I choose, let's ask our audience. So, guys and girls, what is your code coverage target? Like, how much % of your production code should be tested? Is it like 0? Do you like this approach? I think it's great. Like, we just write code, it's the best, and we ship into production.
The most productive. Like.
Who is agree? No? Nobody? OK. Maybe 30%? No? Oh, you're pretty good. 60%? OK, some hands. 80? Oh, yes. Everybody gravitate around 80. What about 100? I think it's also a great target like, to shoot for.
Of course.
And what about 110?
Come on. That's the best code coverage.
So do you want to prove that they're all wrong about 80%, or you want to prove that they're all right? I suggest this myth.
I think like even if most of you raised your hand at 80%, there is common belief that like we need to aim 100. Like we have 80% because we might be like lazy or we need to cut some branches to deliver, but we should all aim at a 100%. Yes?
As this is even written in some books.
Yeah, and I think there are some books who tell exactly the same, that code coverage should be 100%. I read it millions of times. And actually, if we think about it in other words, it means that if you write one line of code, you can always test it. You can write one test that tests this line of code. So today, we are going to do the same. We will be writing like one code, then we'll be writing tests, and trying to prove it. And one important remark here, one important note, we are not going to use a TDD here, because we'll first write code, then we'll write tests. But this is just because we need to dispel myth. In your applications, use TDD, because it's like the best approach. So if the only thing that you get from this presentation, it should be use TDD. So as I am a very responsible developer, I prepared some code. And because Evgeny is principal Java champion, so he is not responsible developer, so he'll be writing tests live today.
What a surprise. Yeah. Thank you for this. OK, so first example, what did you get for me here? You just wanted me to test some sum. I think it should be pretty easy.
I think it was a long time since you studied how to calculate sum. Maybe you forgot as principal developer.
No, I did not. And come on, nowadays no talks happens without AI. I have a copilot. He can just help me. I think it's a pretty good test, and I'm going to get 100.
For some reason, it's red.
It's not red.
It's red because it's different class, I guess.
Red.
It's example 2, and we are...
Ah.
So you see,
AI
trust AI.
AI is bad. Is it better now? What?
What?
Because I'm writing in different file. IA is right here. I should be writing one test.
Yeah, OK. So 1 plus 2 is 3. Do you agree? Even AI thinks that 1 plus 2 is 3, so probably it's...
So should we test it? Should I run like our favorite MVN clean test or, well, package?
Yes, let's test it.
No, let's don't package. We just need verify.
OK. No MVN clean install this time?
Oops.
Who is using MVN clean install?
Please stop. You don't need install. So build successful. I
think that's not enough. Let's open code coverage report.
Let's try. So site, JaCoCo.
Today we are going to use the code coverage library JaCoCo, and it shows us an interesting thing.
What?
We wrote the test, so we expected 100% because we covered everything, but it shows that nothing is covered.
You're kidding me, no?
Yeah, and I think this is my fault. I think I'm guilty here, because let's have a look. From where do you take the annotation test?
It's my favorite JUnit 4.
It's JUnit 4, but let's check which libraries do we have in POM.xml. So
here is JUnit 4.
JUnit 4, and we also have JUnit 5. So which JUnit is actually executed? And the thing is, JUnit 5 can execute JUnit 4 tests, but in order to do this, you need vintage engine. And we forgot to add it here. Like, I don't know if you ever faced this problem, but in my team, in our company, there were a lot of people who forget about it when they did migration from JUnit 4 to 5 and still have some leftovers from JUnit 4, and the tests were not run. So now we see that the code is covered.
I guess we just busted one myth.
So there is one myth that probably is a common belief that if you have zero code coverage, this is always bad. But in fact, it's not always bad. Zero code coverage sometimes can tell you that actually tests were not executed, and this is the way to find out that you have either bug in your code, bug in your tests, you forgot about something, and for example, this issue with vintage engine or using improper JUnit could be found by having zero code coverage. So in some situations, zero code coverage or lower code coverage than you expected is actually a debugging tool for you.
Debugging tool, you say?
Yes.
You know what? I got an idea. Do you guys use Eclipse? Who is using Eclipse? I'm using, and I'm not ashamed of this. And the ones who don't use, do you like some fun? Do you want to have some fun with Eclipse?
You just showed IntelliJ. You don't use Eclipse. Where are you lying?
I sometimes use Eclipse. OK, so let's have some fun with Eclipse. Indeed, I don't use Eclipse, but I inherited Eclipse project. Like we have JaCoCo, Java Code Coverage, and we have ECLEMMA that integrates JaCoCo into Eclipse. And I have to maintain this Eclipse project now. I'm not an Eclipse user. I know nearly nothing about Eclipse. And I'm getting a user report. User says, OK, I want to run code coverage in Eclipse, and when I hover over this item, I get some stack trace. And in this stack trace, there is no trace of ECLEMMA. I don't even know where to put a breakpoint to start debugging this issue. What could I do? So here is my idea. Let's start Eclipse application from Eclipse, and let's debug it with code coverage enabled.
So we are just going to debug Eclipse inside Eclipse.
Or maybe not.
Or maybe not.
Let me check. Probably I did something wrong. Let's start this Eclipse application. No, maybe we're not going to demo it. Sorry for that. Let's try.
So it happens sometimes. Usually it works, but we will probably have some recordings from other conferences with this application. So if we don't manage to show it today, you will be able to see it and other recordings. Sorry for that, but maybe we'll be able to fix it soon.
I'm not so sure. Let me anyway try one more time.
OK. So you see, it's not easy to start Eclipse and use Eclipse.
So
Eclipse is the IDE for advanced developers. So
let's hope.
Let's hope this time.
That's my Eclipse. Lesson to learn, don't do a live coding sessions, right?
Come on.
But I think we will succeed now. So I start debugging.
So you see, relaunch is always the resolution of every problem, we hope.
Yes, now it should be better.
So yeah.
So I started a new instance of Eclipse with code coverage enabled, and I can record code coverage. So here is this menu item that I want to debug. You see some exception happens, and there is nothing about ECLEMMA in this exception. From where should I start debugging? So let me first collect the code coverage from the running instance. Yes, something started. At the same time, I'm resetting what we collected so far. So let me do it, and we're going to get 0. Yes. Now, if I do the same UI actions that we want to debug, I did it, exception happened, I collect coverage again, and I am getting something executed. So here is some UI action. I can go here, see that some code was executed. And now, actually, I know from where to start debugging. This is probably the place where I should put the breakpoint. So code coverage is a nice debugging tool.
Oh, I think we just busted another myth. Thanks, Evgeny, that you managed to do it. So code coverage is not only to measure coverage. You can actually use it just to learn which code was executed and which code was not executed, even in your production systems.
And don't worry, you don't need Eclipse for that. You can do this with like any application and any IDE. Should we move on?
Yeah, let's move on.
You have, I guess,
another example.
Another example.
First example, and then test.
So what do you have
Evgeny starts with test because he is used to TTD.
Yeah. You want to suffer. There is like 4 cases to cover, but maybe
Copilot.
Maybe, yes, maybe Copilot can help me. So What's the best conference in the city, Copenhagen? We believe it's KotlinConf. In Sofia,
Actually, we just are mentioning the 4 conferences that we've been visiting in the last 4 weeks.
Okay, I think I'm done. There is 4 cases in Genome I'm covering.
So that's not fair. I wanted you to suffer. I wanted you to implement 4 cases, and you just used Copilot. Okay. Let's see how good is Copilot.
We want to again check the coverage report, I guess.
And that's funny, because when we did this presentation previous time, Copilot was not that smart, so Evgeny had to copy-paste. So it learns.
Yes, Evgeny learns, right?
Yeah.
OK, tests are green. Let me check. You're not tricking me with JUnit again, like.
You see,
yes,
we have 4
test
genomes.
run as well.
We had 4 cases, and we had 4 tests, so should be 100%, yes. But
Ouch.
no, there is something that we forgot to cover. Let's have a look.
Yeah, but come on, it's not possible. I mean, there is 4 genome cases. Default is not reachable.
So you want to tell me that, OK, we wrote 1 line of code, but we cannot test it?
Yes. I mean,
I disagree.
I mean, even compiler. Why compiler wants us to write this default?
We should reach 100%.
What do you suggest?
Let's try to test it. I think in cases like this, we can use mocking. Do you agree? Let's use mocks.
OK. OK, so we want to mock example 2. It's going to be my mock.
Copilot does not. OK.
Compiler tries to help me, but I don't like what he suggests. OK, do return. Let's return now. When, whatever mock, best conference, example 2. I don't want a Copenhagen. We are currently in Barcelona. And what we want to get a null.
We want to return null for Barcelona. For knowledge for Barcelona, it should be DevBcn. Let's not offend Barcelona. Let's put something else.
Coimbra. Is it better?
Yeah, it's much better. Because the best conference in Barcelona is DevBcn. It should not be null.
OK, and I can optimize assert equals to assert null. Is it better?
Yes, let's run the test. Actually, since you're a principal developer, you never write mocks, so this is the first time Evgeny is writing the mock.
I hate mocks, come on.
And you see, you probably did it wrong.
No, you see, that's why I hate mocks. I heard, and it's even, there is some bug tickets in Mockito, bug tickets in JaCoCo. Mocking doesn't work with code coverage.
Yeah, let me explain what happened. Usually, just to clarify, mocking mechanism, we'll build some, I don't know, wrapper or whatever, depending on library, and instead of executing the code that you mocked, it will return something that you asked it to return. In default case, for example, null, and if you did some stubs, it will return the value that you wanted. So we told to Mockito that when we want to execute best conference method from our mock, return null.
That's what I want to test, no?
Yes. But that does not actually execute the best conference method, and code coverage tells you that it was not executed. So code coverage here is correct. So when you're mocking, you should not mock the method that you are testing. When you write mocks, you need to mock your dependencies.
What should I mock?
So here, we need to mock a enum.
Mock enum? Come on, enum is final in Java.
And what? So what? Who thinks that we can mock enums? Who thinks that we cannot mock enums? I think we just broke the audience. They are some in Schrödinger state.
OK, so if I'm mocking enum, I want a -1 when we are asking switch is done by ordinal. So here is ordinal. And this time, when we ask for not a mock, but a real instance, best conference, this time we can ask whatever we want. No, this time we need to pass a mocked enum.
And it should be null.
Will this work? Come on.
Let's try. Yoo-hoo.
Wow. But
so
come on, that's a black magic.
Enum is final. 100%, isn't it like our goal?
No. I don't trust you. You know, like, it usually happens with a black magic. it stops working, right? It breaks at some moment in time. Can I try, currently we are on what? We are on Java version 21. Can I try early access build of something like 23 that it's going to be released?
OK, so you know when you're doing a talk at a conference, one of the advice, don't update anything like before you talk. So we will update it right in the middle of our talk. OK, you're crazy. Let's do it.
It doesn't work.
So you see,
I told you, black magic have a tendency to break at some moment in time. And come on, I don't want to, we're testing something simple, stupid. I don't want additional dependencies that can break at runtime if I upgrade my Java just for this. You know, we are what? We have now Java 23. A long time ago, we got switch expressions. And switch expressions can be exhaustive. They don't require default. Can we just refactor this stupid code? Like push down, join, inline. Like, it's not needed anymore. And is it not, as it is not needed, I can just drop that stupid test.
Yeah, and we can remove dependency on Makito. So you see, this time it works with Java 23 early access.
Do you want to see the coverage? 100.
Yeah, wow. So if you can use switch expressions, use them. And I think we just busted another myth that code coverage actually works with mocks, because we've seen it a lot in some issue trackers on the internet and StackOverflow that code coverage does not work with mocks. But it works with one remark: you should know how to write mocks. So let's go next.
OK, let's move forward. What do we have else?
So this time we have another switch.
This time you have few cases. OK, what do you want me?
Yeah, I want you to actually implement the test for my function that calculates the perimeter, because like it was a long time since I calculated perimeters in my life.
I think it's pretty easy.
So it should be.
Should be fine, right?
Yes.
Let's try. Oops.
So.
What?
Again, strange. Why are you so surprised? You developed this tool.
What? There is
you
two
don't know
cases.
how it works?
Come on. How it's possible that there is some branches like that?
I think it's exactly what I told you not to do. I told you not to update Java version. You did it, and maybe that's it.
OK,
so
let's
probably
try.
JaCoCo is not ready for 23.
Let's try go back to 21. Yeah, you see 100.
So,
I will fix JaCoCo, don't worry.
So you see, sometimes code coverage can depend on compiler. So you cannot assume that you just changed Java version and code coverage is the same, because unfortunately that's not true. Sometimes
code coverage in Java world almost depends on the compiler. Whatever tool you will find, it works on the result of the compilation, not on the source code. So it always depends on what compiler produced.
Yeah.
I think bested.
Move forward.
Let's move. Oh, this time it seems to be, again, two cases.
Yeah, and so far we've been like only using JaCoCo here to test. But you know, there is a way to run code coverage in IntelliJ.
And I see you learn it. You use switch expression. You actually knew that switch expression exists. Now it's two cases, all fine, code coverage in IntelliJ. No problem. Like 100 from a first shot.
But OK, we tested all the cases, so it should be 100. But since we work at Sonar, and we need like at least 1 or 2 slides about Sonar, let's check the code coverage in Sonar, because in Sonar you can also see the code coverage. And just the fact that Sonar, SonarQube, Sonar Cloud doesn't calculate code coverage. It just takes the report from JaCoCo and shows it to you. So
you know this, right? So we're expecting exactly the same results as in JaCoCo.
Yes. Let's firstly check what it shows.
I think internet is not great here.
Okay, maybe we can use our...
No, it works.
Oh, it worked. Because okay, this time I developed this tool, and if it does not
this
work,
tool is,
I'm a little bit ashamed.
This tool is a little bit slow. You should improve performance, right? We're going to come back and I'm going to fire a back report. It's utterly slow for the live demo.
You know where to fill in back reports. Let's not do it right now.
But OK, to not spend time, we actually executed this MVN Sonar earlier, so here is the result.
100%.
Got a branch here, 100%.
And let's look at JaCoCo reports, because since Sonar just reads JaCoCo reports, it should be the same, yes?
Why do we even need to check? It imports JaCoCo report.
But let's look, just for fun.
Sorry, I didn't let it actually finish.
You didn't let it finish, and that's why we need to look there. So you see, Sonar reads JaCoCo reports, but Sonar says 100%. JaCoCo says 90%. So we just busted another myth.
Yes, you know why Sonar is probably looking on what? On line coverage, and line coverage is 100, but instruction coverage is not 100.
Look at the slides.
Okay.
Because we just busted the myth. Okay. That code coverage is the same in all tools, because it depends on the tool. Sometimes tools measure code coverage differently, and sometimes they just measure different things. And let's actually double check what JaCoCo is showing to us. So
JaCoCo says that we didn't cover the body of the Lambda, and that's pretty fair.
And indeed, here you can see, while IntelliJ, while Sonar showed with us that we covered 100%, we did not, because we forgot to cover the exception path. We forgot to cover the Lambda when exception happens.
OK, and this time, I think I know how to use mocking. I'm going to spy on existing instance, and you told me that I should mock the dependency. So our dependency is actually, I want an optional when we ask to load some conference, and we want some exception to be thrown in this case.
Yeah, let's try.
Let's don't start Sonar, as it is quite slow.
Don't throw stones at me, please.
Yay, it's green now.
So we see JaCoCo was actually right here, because we forgot to test something. And, but since we started looking at other tools, let's check out another tool.
Which one?
Ptest. Have you heard about mutation testing? So not a lot of people. Briefly, I'll tell you what it is. So mutation testing introduces changes to your main code or your production code, and then executes your tests. If all your tests passed, it means that there is a way to modify your code that is not tested. And this situation is called that your mutant survived and your tests are bad. If this situation caused the tests to fail, it means that mutant was killed and your tests are good enough. So we can use mutation testing to actually assess if if we forgot something.
Apparently, we forgot something according to ptest, what it says here.
Yes, and here, mutation testing told us that they replaced the return value of Lambda with null, and then the mutant survived. In order to check it, let's do exactly what it suggests. Let's replace it with null.
But that's easy. This should be null pointer exception.
Yes, and let's run the test.
Oh, tests pass.
So you see, we changed our code, but the tests still pass. And it means that our mutation coverage is not the best. We just busted one more myth, I think. Even few myths. That first of all, that line coverage is not enough, because on one line there could be more instructions, conditions, and you need to test all of them. And the second myth that we busted was that 100 code coverage guarantees test quality because it does not. Sometimes when you see 100 in code coverage, there still could be something missing. For example, what mutation test showed us. Let's add another test case. And maybe while Evgeny is writing, I'll explain what happened. When we replaced it to null, we actually showed that received a null pointer exception. But because null pointer exception is a runtime exception, our tests still pass. So we need to test the exact class of runtime exception.
OK, let me restore the code back. And I think I wrote now better variant of a test.
Yes. So we'll run.
It's going to be green, but
so
we
now
need to run mutation coverage, right?
Yes. So now we tested everything. And probably mutation testing will show us that it's fine. Come on. So slow.
Yes,
yeah, so you
100%.
See, mutation testing shows us 100%. But let us introduce one more mutation. Let's change the error message. Like change or remove it at all.
OK.
And let's run the tests. Actually, you see probably it's Sonar lint or IntelliJ tells you not to do this.
No, a method reference.
Ah, OK, it's a method reference. OK.
Oh.
So you see, we changed the error message, but mutation testing told us nothing. So we just busted that even mutation coverage does not guarantee the quality of your tests. And the fun fact.
You know what?
Yeah.
Our users actually, they wanted that we load this from the database. And we are not testing this either.
So like 100% of mutation testing, mutation coverage, doesn't even guarantee your quality. No tool can guarantee the quality of your software. We still need a human because no tool can know about the requirements to your software. We can use them, but we cannot completely trust them. Like, we should be a bit smarter.
Speaking of the quality, like, we just executed wonderful Sonar, so let's have a look at Sonar. Here is our project that we just built. It has 100% coverage. And let's have a look on another project. By chance, I pick up my favorite JaCoCo project. It doesn't have 100% coverage.
Yes. JaCoCo, the code coverage measurement tool, doesn't have 100% of coverage?
Yes, shit happens. So
how can we even trust this tool?
If we compare these two projects, which one we will trust more?
Of course, this one. It has 100%. Come on.
But this project does nothing, and this one been there for more than a decade. I would trust this one.
OK, maybe you can show
let's
what's
have
not
a look.
covered.
Let's have a look what is not covered. Come on. Here is one of the examples. It's a switch by enum, and well, the default case is not covered. And come on, in this tool, I'm not going to introduce a stupid dependency on Makita just to test this default branch.
Switch expression.
Sorry, I cannot use because our users wanted Java 5 compatibility. So not this time.
As I told you in the beginning of the talk, we all are doomed.
But I think we just busted another myth.
So you see, JaCoCo supports Java 5.
I think we busted another.
I think we busted another myth that, OK, we should not blindly trust the percents, and we should not use the percentage of code coverage to think about which project is better. Because it's not for managers, it's not for comparing the project. Code coverage is a development metric, and we need to use it in the development purpose. And yeah, don't show it to managers. Use it as developers.
Are we over?
I think there is one more thing that we need to cover, because so far we've been focused on code coverage as a metric, but we are engineers, we love physics, and probably you remember there is an observer effect from quantum physics. The fact that we are observing something, like we do in code coverage, actually changes the behavior of observable. Code coverage, does it change something, for example, performance?
Easy. Let's check. This time I came actually prepared.
First time.
Yeah, first time. I have a benchmark. Let me start it, and while it's, oops. No, class not found. That's easy fixable. I probably need to compile my code. or even package.
OK.
Yes, while it's running, I'm going to explain what we are doing, what we are benchmarking. So I have Fibonacci calculator. It's super stupid, simple. Given the Fibonacci number, we are computing, given the index of a Fibonacci number, we are computing Fibonacci number. I'm not going to test it. You're going to trust me that this one is working as intended, and it's not our goal to write a proper Fibonacci number calculator. We want to test the performance. So we are taking this. We are going to execute original version of this code. Then we are going to instrument it using JaCoCo code coverage engine. And we are going to instrument it also using JetBrains coverage engine, the one that is default in your JetBrains ID. We are going to run it to compute the value 10 of the Fibonacci number. We also have an operation just to make sure that our benchmark makes sense. And we got the results. If you look at the results, what do we see? OK, no operation still takes some time. This is what benchmarking infrastructure takes. Here is our original. It's slower than no operation, which is expected. So our benchmark probably makes sense. Then we see the JaCoCo. It's even slower than the original, but not that much, actually. And then we see the JetBrains. And JetBrains is what, like 4 times slower than the original. So yes, I think we just busted myth that, well, measuring code coverage does affect your application. It at least affects performance.
Yes, and you should keep this in mind, because if you're executed in your IDEs, it takes time for your like execution and IDEs, and if you do it too often, probably it will affect your performance and your productivity. So keep that in mind.
You think we are over with?
I think we are over with this myth. So let's.
OK.
So there was very first myth that we actually haven't busted yet. We want to ask you, like, looking at what we told you during the whole presentation, do you think code coverage should be 100%?
Well, I don't think it anymore.
Let's summarize a little bit. We think, and we hope we proved it, that code coverage should not be 100%. But code coverage should be at the level when everything that is supposed to be covered is covered. And unfortunately, this is much harder to achieve. But we are human. I think we are intelligent. We'll figure this out. In the ideal world, it would be nice that we can reach 100. But you know, the world is not ideal. We have compilers. We have compiler artifacts. We have different not ideal tools. So we could not reach it. In the future, it would be nice if the tools like JaCoCo or Sonar will introduce the features where we can accept code coverage or say we won't fix or it's a false positive. So we can cut it, and actually we can achieve 100 within some context. At the moment, tools are not ideal. We don't have it. We have to somehow deal with this.
You know what happens every time you introduce something like the way to accept or won't fix or mark the code as?
What happens?
Who is going to watch the watcher? Who is going to guard the guardian? Manager is going to immediately come and say, now I want to track not a code coverage metric, but this one, how many lines of code were accepted. We are doomed all here, I think.
Yeah. So I hope we busted this main myth. And I think there are a few points that we want you to take from this presentation. First of all, code coverage is a developer metric. It's not for managers, and it's not an ideal metric. So tools are not ideal. As you can see, tools make mistakes, tools have a lot of false negatives, but they're still helpful, because even if you have false positive, even if you have some miss of code coverage, while you're investigating it, you'll probably learn something about the tools, about the industry, and about your project. So use them, and never try to please the tool. Never try to achieve 100% just for the sake of 100%. Today, we tried to do this. We introduced a lot of stupid tests. We introduced some mocking. We introduced the testing of the things that we don't need to test. So don't do this. Try to test only your code. Never try to test what compiler generates for you. So use these tools smartly. They're here as your co-pilots, as your friends or co-workers, but they are not, should not control you. So I think this is it. Thanks a lot for attending our presentation. I hope you learned a lot of new things here and had some fun.
We ran out of time. But maybe we have just a few minutes for a few questions, if you have them. If not, again, thank you. Or if you have questions but shy to ask them on stage, feel free to catch us outside, and we will talk about whatever you want.
That's it.